Alrighty, welcome back everybody to our monthly program of Hack Central, where we are diving into more advanced computer science topics. I'm talking about some stuff which is a bit more interesting, going to some more advanced things which we usually are not able to cover with our JavaScript and Python courses. As always, thank you so much for watching and coming in. We got a cool, sort of different type of thing planned for today. You know, over the past couple months, we've been talking a lot about machine learning with Python. And today we'll be talking and diverging into a sort of a different path and getting into some more unique things. You may be asking what that unique thing is. Labdhi, you want to talk about it?
Yeah, definitely. So we will be talking about a bubble sort. The bubble sort is a sorting algorithm that basically sorts any kind of array, is something that we talked about, into an ascending order or a descending order.
Exactly. So you're probably used to us talking about like algorithms like linear regression, k-nearest neighbor. We talked about k-means, a bunch of those. And today it's a bit different. It's a bit more simpler for sure, but this is going to serve as a good sort of foundation for our upcoming January programs, which we'll be talking about a little bit as well. In case you guys don't already know him, my name is Rayaan Siddiqi. I'm a senior at James B. High School with Labdhi. Left a program, made apps for the App Store, made a dozen different websites. I've just released a book on Amazon called The Switch Up. You can find that out all on my website at RayyaanSiddiqi.com. And my partner Labdhi.
Hey guys, so just like Rayaan, I am also a senior at James B. High School. I'm a hackathon organizer, winner, and participant for multiple hackathons, and my current CS research topic is Dijkstra's algorithm.
Yeah. So some of you guys might be thinking, wait, what is Dijkstra's? It sort of ties into today, right? Might be that idea of sorting. So that's pretty.
Yeah, definitely.
Hard to pronounce, so for sure. And guys, you might be remembering earlier I was talking about some of our other programs. Remember, we got a bunch of programs with our Tech Bytes. Every other Monday, we got actually 2 more of each of these left. So with Python, we got 1 more next Monday. That's going to be the last one for our Python course. And then we got 2 more this Wednesday and the next Wednesday for our JavaScript course as well. The timings are a bit off. We have changed to 4:30 to 5:30. It's a bit of a typo. And then we have our last Teen Trivia for 2020 this Friday at 5 p.m. as well. And then starting January, we're actually going to be starting some new programs. And they're going to be building upon what we're learning about today, that idea of making efficient programs, doing some stuff out of the box. And we'll be talking more about those in the coming weeks, so stay tuned for those as well. So now let's get back to today's idea and talk about what we're going to be doing with the bubble sort. So we're going to be utilizing, guys, the language of Python once again today. Now, you might be remembering that we've used Python a bunch in this Hack Central program, you know, whether it be with machine learning algorithms, whether it be that one time we were looking at how we can automate tasks in the computer, how we can type out emails for us and all that cool things. We always tend to use Python, and today's going to be no different. We're going to be utilizing Python once again because Python is a super common language for writing algorithms, and it's very commonly used in higher levels of programming, whether it be backend. You may or may not have heard about today. Google was crashed. Google had a huge outage in the morning at around 6 a.m. for around an hour. It was because of some of their front end issues, but Python is one of the languages which is able to help save the day. And remember, Python is a super simple and easy language to write. And it's going to be a language we're going to be talking about more in January as well. But if you want to learn more about it, you can definitely check out our YouTube channel, the Schomburg Library, and the Tech Bytes playlist, where we got a bunch of months of material posted as well.
All right, so again, just to reiterate, today's topic is the bubble sort. Now, before going into a specific bubble sort, let's take a look at what sorting is and what a sort algorithm does. So a simple way to describe a sorting algorithm is it's a kind of method that allows you to order things in an array, whether they are numbers or sometimes characters as well. So here in the image is a very nice representation of what sorting means. Basically, from a jumbled group of letters, BDAC, that sorting algorithm will sort those letters into A, B, C, D, ascending. And yeah, that's it.
Yep, so it's this idea, guys, of being able to sort however we like. You know, Labdhi was talking about how we can sort of sort letters from jumbled to an alphabetical order. And that mindset can be applied to anything, whether it be with numbers and letters, something cool to remember. So let's talk about there. So you're probably looking at the screen right now. There's a bunch of sorting algorithms. We got quick sort, we got bubble sort, we got a merge sort, insertion, bucket. We got a whole list. And believe it or not, this is not close to the whole list. And you might be asking, why are there so many different sorting algorithms? Well, the main reason is why, because there's multiple ways of doing something. And today we're going to be talking about how to sort an array where there are multiple numbers. So why are we choosing the bubble sort out of all of these arrays? Well, out of all these options? Well, the main reason is because the bubble sort is sort of an easier version. It's a good way for us to get those building blocks and work our way up to harder level sorting algorithms, like the one Labdhi's studying right now, that Digistacatras, can't pronounce that correctly. That's a much more advanced sorting algorithm involving nodes, and it's a whole other ball game. But in order to get there, you got to start small, like we've always done. And today we're going to be starting off with the bubble sort and talking about how that works and coding it as well.
All right, so again, so what specifically bubble sort does and how it's different from other sorts, let's look at this video first, and then we'll kind of explain what it does to make it easier. All right, so in this video, don't mind the sound, but basically these bars represent different number values, and basically this algorithm is going through each value and sorting the list. As you can see towards the end of this screen, all of the bars are looking as if they are being sorted. And basically bubble sort sorts a bunch of like an array of numbers in this manner.
Exactly. And you guys are probably taking a look at this and be like, hey, this is taking quite some time. Like, it seems like it's pretty inefficient, right? Meaning it's taking a long time. It's going every time, and there's only one bar being sorted at one time. So if, say, we have, right now today, we're not going to be dealing with a bunch of data, say like 10, 15 10 numbers at max, right? But if in the real world where we have hundreds of thousands of pieces of information, if we're going to be utilizing this sort, keep that in the back of your minds. That's pretty inefficient, right? Somebody can't wait that long. And now, after a minute, this is a simulation. If it's going much faster, we finally finish.
All right, so just to describe what we saw in that video, that visualization of a bubble sort is basically that algorithm was swapping values from its original position in that array to the actual position in a sorted array. As Rayaan said, this is a very slow working algorithm. Specifically, its time efficiency is called something that's towards a little bit advanced in algorithmic programming, but it's what's called O and then n squared, because you're going n squared, so n meaning the length of the array, and then squared, that's the amount of time proportional to the array squared. So yeah, next.
Yeah, that if you guys are at all confused, that's something which we'll be talking about more starting in January when we're dealing with multi algorithms. Like, what does O n squared mean? It's I'll sort of visualize it, but don't be offended if you don't understand. It's totally fine for now. So now, how about if we actually take a look? And before we start programming it, let's take a look at how this works as a visual example. All right, there we go. All right, so let's start off with, this is going to be our bubble sort visualization. Oh, that whiteboard is pretty. Okay, give me 1 second. I'm going to open up a different app and do it there. Oh, looks like we can't share our screen on iPad. Okay, let's try something else. Give me 1 second, guys. All right, we'll try to make do with this then. All right, so it's the idea of sorting, right? So say we have firstly an array, and I'm gonna change that color. So say we have an initial array which has the numbers unsorted right now. We'll say it as 8, 3, 6, 1, 4, and 9, right? So we got 1, 2, 3. We got 6 elements in our array right now, right? And so sort of going to this idea of how does this sorting algorithm actually work and why is it so inefficient, right? So the way it works, so say I'm going to actually label this. I'm going to say this is going to be iteration number 1. Iteration number 1 meaning the first time we're going to loop over this array. So the way this algorithm works is that it looks at 2 values which are next to one another and compares and checks. Is 8 greater than 3? Well, yes. So meaning we should swap the 2 elements, meaning 3 should go over there and 8 should go vice versa, right? So we're going to do that, but you're probably going to notice that it's going to get pretty lengthy. So the first time we're going to go through and perform our checks, we're going to check 8 and 3. Is 8 bigger than 3? Yep. So we're going to put 3 there and 8 goes over there. Now we're going to check between 8 and 6. Yeah, 8 and 6. So is 8 bigger than 6? Wait, I'm doing...
Yeah.
Wait, is it between these two, or do you go next to?
It's between 8, that value, and then the rest of the array.
Yeah, okay. So now we're going to look at 8 and 6, right?
Yeah.
Yeah, okay. So now we're going to take a look at the new value we have, and 6. So is 8 larger than 6? Well, yes, it is. So we're going to swap out once. I believe I'm doing this incorrectly. I think it's from the original array, right? 8 and 3, then 6 and 1.
I don't believe so. I think it's just 8.
Okay, so okay, all right, I'm getting a weird feeling about that. Okay, so then we swap again. Then we're gonna have 6 and then 8. And now once we swap these two, we're gonna take a look at 8 and 1. Is 1 greater than 8? Well, no, it's not. 8 is bigger than 1. So we're gonna have to swap that again and put 1 in front of 8. Now we're gonna take a look at 8 and 4. Is 8 greater than 4? Yes, it is. So 4 is gonna go before, and then 8. And then we're going to take a look at 8 and 9. Is 8 bigger than 9? No, it is not. So we're just going to put 9 at the end. Now you're probably taking a look right here that this is an example which worked nicely in our favor. However, we're going to have to keep on going over and over and over again. And now going towards that idea of what Labdhi was talking about, she was saying something called O(n) squared. Now, what does that mean? Well, O(n) squared, basically what I want you guys to think about is that this is a way for us to see how much time does it take for us to run this algorithm. And basically what this means is that n is representing the length of our array. And the length of our array, remember, is how many elements we have, which is 6. So 6 squared means 6 times 6, which equals 36. So this is O to the 36. And why is it n squared? Well, it's n squared because we're performing a swap between every 2 elements, which gets pretty repetitive to say the least, right? This is an example which I guess worked nicely in our favor, and which is why. But if we had many more numbers, you could probably take a look and see why if we had to do this for every 2 elements, it would get pretty repetitive. Alrighty, so with that out of the way, how about we take a look at how we can make this long process much quicker with a couple lines of code in Python.
Yeah, so Rayaan said a couple lines of code. It's not exactly 2 lines of code, but luckily it's very, the code that we are going to run is very short. And here's how. All right, so open up Replit and let's code. So in our bubble sort code, we will first just make a function, def, let's call it bubble. And inside this, we're going to pass in a parameter, which will be our array. We're just going to call that R. And okay, so in our actual algorithm, our sorting algorithm, what will we first do? Well, what Rayaan went through was basically we are going to iterate through the array a number of times and do an operation in that iteration. So to iterate through an array, we will use a for loop for I in range. Okay, so what should this number be? Now, usually to iterate through a loop, we usually put the length of that array. So len r. So this will be for I in range. Let's say we just, before going through the code, let's make our variable array. And let's just use the same numbers that Rayaan used for the visualization, which were 8, 3, 6, 1, 4, 9. All right, so the length of this array is 6. Now, do we have to iterate through 6 times? Do we have to iterate through less than 6 times or more than 6 times? We don't know yet. Let's keep 6 right now. So once we do iterate through this array once, what do we want to do? Well, the reason why the time efficiency was O(n) squared is because there are nested for loops in this bubble sort algorithm. So we're going to write another for loop inside that for I in range. So let's say for j in range. And in this, instead of just saying len array, we're going to say len r minus 1. And I'll explain in a bit why. So once basically this goes through the array without going past it, but this iteration goes from 0 to 6. That means 7 times, not 6 times. And I'll explain in a bit again. So inside this main iteration that we're going to iterate again for inside the for I loop, we're going to compare two values. So first we're going to compare if our I is greater than our j plus 1. Yes. So basically what this means is, oh, sorry, not ri, my bad, rj. Basically, it's comparing 8 and 3. So if rj is greater than rj plus 1, and over here, I'm going to confirm what Rayaan's intuition was, it was correct. Basically, instead of comparing 8 and 6, you compare 8 and 3, 6 and 1, 4 and 9. Sorry about that, Rayaan. And basically, so we're going to compare if 8 and 3, or 8 is greater than 3. Well, if it is, what shall we do? We shall swap those numbers. Now, to swap two numbers, you can't just say rj is equal to rj plus 1. We have to set a temporary variable equal to rj, set rj plus 1 equal to that temporary variable. Oh, wait, sorry. We have to set rj equal to our new value, which is rj plus 1. And then finally, we set rj plus 1 equal to our temporary variable that we made. So what these 3 lines of code basically do is they just swap the values of the basically first value of the array and the second value of the array. Now, this is just between these 2 values. What for j in range length r minus 1 does is it compares 8 and 3 and then switches, compares these 2 values, switches if needed, compares these 2 values, switches if needed, compares these 2 values, switch if needed again, and then finally compares these 2 values and then switches if needed. So that's what this inside loop does. All right, so why do we need to now iterate through one more time if we already went through all of these values? Well, let's see. So our code over here is done. we're just going to return our array, and then finally test out this function that we made by saying print bubble, and then we will input our array into the parameter we made for that. There we go. So if we do run this, we get 1, 3, 4, 6, 8, 9. And if you think about it, 1 is less than 3, 3 is less than 4, 4 is less than 6, 6 is less than 8, and 8 is less than 9. And that's how bubble sort works. So, I kind of stalled off the question for why we needed this final loop. Well, once we did change this first array into, by comparing, so our first array was 3, 6, 1, 4, 8, 9. So now these last two values are fit perfectly. And that's again what we saw in that visualization in that video. As the bubble sort started working, the last values started arranging themselves. And that's basically what's happening in here. But this is the first iteration for this for I loop. Now we have to iterate through a number of times to make sure that every single value in this array is fit into that correct position of an ascending order. And that's why we have to iterate through 6 times. And that's basically it, guys. That's about not even 15 lines of code. That's like about 10 lines of code.
Yep.
And we have bubble sort array completed.
Exactly. And guys, the main part, which I would say, which you got to highlight, is that that swapping is the most important aspect of this. When you hear the word bubble sort, immediately link it to the word swap, because that's what's occurring here. And although it's sort of not the best timely thing to do, it's still the main thing which is happening with this bubble sort. You're swapping elements left and right, and eventually you'll end up with the sorted array. That's the main idea.
Yep. I'm going to stop sharing.
All right, guys, so just to finish it off, we have coded, we have done a whiteboard explanation as well. And just going back to that idea of why this bubble sort is usually not implemented in the real world, if you go back to that idea of like a company like Google, right? They have millions of pieces of information. It wouldn't make sense that they're sorting all their data in such a long time manner, right? Wouldn't really make sense. So that's the main drawback to this bubble sort algorithm. But there are a bunch of other algorithms which are much more time efficient algorithms, which we'll be talking about in our upcoming courses in January. So if this type of stuff interests you, we would definitely recommend that you join our Google Classroom, and also look out for our January courses coming out soon as well. As always, guys, thank you so much for coming out here today. If you have any questions along the way, you can, if you're watching this at home on YouTube, you can drop us a comment on our Google Classroom. Either Labdhi and I will be sure to respond. But guys, if you are interested in our JavaScript course, this will be this Wednesday, and then our teen trivia this Friday as well. Have a good week, guys. See you.
Bye.